I am so happy to see you. Me alegra verles. Welcome. Thank you so much for being here. I am sorry that we are late. A little bit late. I don't know what happened. Technical issues with the computer. Imagine. We don't have a lot of time. I think we have about 40 minutes at most, right? So let's see. It's not going to be. It's going to be a very, very, very fast talk. So we don't have a lot of time. So as always, I recommend that you take a look at these slides. This first slide is the most important. It's where you're going to find the code that we can look at together later on. It's for your own reference, for your own edification, for your own notes later on. You can find the code there. You can find information about me. My name is Josh Long. It's very good to meet you. I'm a Spring developer advocate on the Spring team, and I have been for almost 10 years now, officially, and a lot longer unofficially. I am on Twitter. I'm curious, how many of you use Twitter? 2019, Twitter. 2019, Twitter. Okay, the rest of you, get on it. It's a good place to be. It's a great place to be. It's the new IRC. It's where the developers that drive the open source that power your business are. So go there. A little bit about me. I work in the Spring team. You can find me on WeChat. I have training videos online. I wrote a book called Cloud Native Java, all about Spring Boot, Spring Cloud, and Cloud Foundry. The book is not yet in Spanish. I would like it to be in Spanish, though, so that would be good. Un día. I have a podcast every Friday where it's just me talking to people that are smarter than I am about different things in the ecosystem. Every Tuesday, I do a roundup where I have the news in the Spring ecosystem. Every Wednesday, it's me on a YouTube video talking about some corner of the ecosystem. And of course, I've got a new book called Reactive Spring, and that's what we're going to talk about today in our very little time together. We don't have a lot of time, so we're going to talk about reactive programming. And to understand reactive programming, my friends, we need to first understand what motivates it. That is to say, why do we care? What are we trying to solve? The problem today is that we're trying to address greater scale. Oh yeah. Good stuff. We're trying to address greater scale. We're trying to handle more users. And this is a new demand that we really only had for a lot of us in the last 10 or so years. And this demand is driven by the need for example, microservices, for big data, for I/O-intensive things. The more input and output that we do over the network, the greater the need to be more scalable, to handle more users. And the reason that we have this need is because traditionally our approach to building I/O-intensive applications was connected to our ability to scale out by adding more threads. Well, threads are expensive. And even when hopefully in a few years, hopefully they will not be expensive, but even when they're cheap, and with Project Loom and these sorts of things, the nature of the things that we are doing, these asynchronous interactions over the network, are dangerous, right? There's lots of things that could go wrong. And so we need to rethink the way we do programming. We have to rethink the way we think about data. And in particular, we have to think about the way that we work with data. Instead of sitting there on a thread waiting for data to arrive, instead of just waiting and waiting and waiting, instead, we need to be more mindful of our operating system. We need to give the operating system a hint that something is being done and that it can have a thread back to do something else with it. And also, since we are aware of the fact that we're doing something over a network, since we're doing things like cloud computing and microservices and so on, we should be more mindful of the fact that there are possibilities for failure here. We need to care about those failure modes. It's no longer enough to just make a call and assume that everything will work. It'll just be fine. That's not a viable strategy anymore. And so we have to address this. And the way we address this is with reactive programming. It's a way of rethinking the way we work with asynchronous streams of data. And if we are willing to embrace this rethinking of the way we work with asynchronous streams of data, then we have some opportunities for incredible scale. One of the things that reactive programming gives us is the ability to disconnect the thread on which a request arrives from the thread on which the response for that request is sent. Put another way, we can get a request and then give the thread back until we have a response to send back. This gives us the ability to do other things with that thread. It allows us to scale to greater heights. This is very important. The question, of course, is if we're doing something fundamentally different, if we are changing the way that we build software, then we need to integrate whatever we decide to use into a lot of different places in our application stack. Isn't that true? Because there's lots of different places where we do input and output, for example. There's lots of different places in our stack where we talk to other services, where we deal with other things. And so whatever abstraction we decide to use needs to be well integrated at the different layers of our application. And this is where Spring, I think, offers the most compelling solution. In 2017, we formalized our integration of Reactor. So we've had support for a reactive programming model called Reactor since 2011. In 2017, it became part of Spring itself, right? It ships as part of the programming model in Spring. We released a brand new reactive web runtime called Spring WebFlux. Since then, we've also released a number of different APIs, including Spring Data K, Spring Security 5, Spring Boot 2.0, Spring Cloud Foundry, and so on. And this supports reactive programming from top to bottom, right? From the web tier to the data tier to the security tier to the microservice tier, all the way out. So now we have this integrated opportunity. And at every level, we need to have support for reactive programming. So whatever abstraction we decide to use needs to be well supported and at all these different tiers. For this, we have the Reactive Streams specification. The Reactive Stream specification was created several years ago by Pivotal, by Netflix, by Lightbend, by the Cloud Foundation, and it is a sort of common ground extraction of APIs to describe asynchronous streams of data. Very, very useful extraction of these APIs. Now, this is a very, very simple set of interfaces, these 4 interfaces in the Reactive Stream specification. Very, very simple. It's Project Reactor from Pivotal and RxJava from Netflix and so on that add value to these very simple interfaces and make them usable. And then Spring understands these types. It's because we have this entire sort of top to bottom sort of arrangement that everything works so nicely. So we're going to see how all that works today, as usual, by going to my second favorite place on the internet. My first favorite place, of course, is production. I love production. You should love production. But if you aren't already in production, you can begin your journey here at my second favorite place on the internet after production, start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and they cannot sleep, start.spring.io. And if you suffer from indigestion, a sour stomach, after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a new application today, my friends, using the latest and greatest versions of Spring Boot. We're going to use 2.20 M6. We're going to build an application called the reservation-service. It's going to be the reservation service. And we're going to build an application that uses, let's say, Lombok. It's going to use RSocket. It's going to use the reactive web support. I think that's it. I think that's enough, actually. Oh, we need some sort of data tier. And so here we have a number of different options for data. We could use R2DBC. R2DBC is still fairly experimental. It allows us to do reactive SQL data access, right? SQL. We can also use one of the NoSQL data store options like reactive MongoDB, right? So reactive MongoDB, that's a fine choice. We can also use Cassandra or Redis or Couchbase or something like that. And of course, I'm happy with our selections, but I do want to make a brief trip here to specify some options. People get confused by this. They don't know when and where to choose which options. So let's explore, okay? Let's take our time and explore these options. You have a few choices here, The first choice is the choice of packaging. What type of packaging should you use in 2019 if, by some terrible accident, you are somehow transported to the distant, distant past, far, 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 far from modern help? Then choose .war. But if you're here with me in 2019, then choose .jar. This is a big part of my overarching and guiding personal philosophy of make jar, not war. And again, lots of options. Okay? Now, We have also the choice of packaging, and the choice of JVM version, and there's a couple of options here. One of these is wrong. One of these is wrong. It's not just technically wrong, it's also morally wrong. You need to use at least the latest and greatest stable version of Java, which right now, the long-term supported version of Java is Java 11. To use Java 8 in 2019 is not just a technically bad idea, because you are missing out on all the security and performance optimizations, not to mention all these great new APIs, but it's also the morally bad idea, right? It's morally bad. Do you want to go home and explain to your children that you're still using Java 8? Are you ready to have that discussion? I think not. I think not. No. We use Java 11 because it's the only way we can carry our head high. Okay? Now, I'm going to generate a new project. Here's my new project here. Okay, I'm going to open this up. Here we go. And this is just a regular Spring Boot application. I'm going to open this up in our IDE. Doesn't matter what IDE. And we're going to just write data to the database. I've got MongoDB running in the local machine there. Let's see. Wait for it. Wait for it. Oh, I hope the Wi-Fi is fast. Who's using BitTorrent? Okay. Good. Good. Okay, so can you see that font? Is that too big? Too small? Let me make that a little larger. It's only the size of a football stadium, okay? Good. So here's our application. We're going to save data to the MongoDB database. I'm going to map an object to the database. I'm going to create a field called ID. I'm going to map it to the primary key of my document. In MongoDB, a document is like a row. I have a collection, which is like a table. And so this is the essence of what I want to do. I'm going to create an object with this two fields, right? ID and name. Now, of course, it's Java, right? So I need to create getters and setters and toString and all that kind of stuff, right? So terrible, so terrible. Look at that terrible code. Yeah. No. Instead, use Lombok. Lombok's a compile time annotation processor. Or use other languages like Kotlin or Scala or Groovy or literally almost anything else, okay? There we go. Now, we have our basic entity, and we're going to persist this into the database. We're going to create a thing that writes data to the database. I'm going to manage that through the CRUD repository. Here we go, reservation string, okay? It's just a repository, and it's going to handle reading, writing, updating, deleting. It's just an interface. Spring will provide the implementation for us, and you can see there are usual methods here: find, all, count, delete, etc. Three things that are new to, I think. First, the publisher. This is one of the Reactive Streams APIs. It publishes data to a subscriber asynchronously. The subscriber consumes the data. When it subscribes, it's given the subscription. We'll come back to this in one moment. When the data arrives asynchronously, the onNext method is called. When there are errors, the onError method is called. And when it's time to stop processing, the onComplete method is called. Now, we did skip over this. Let's talk about this subscription. Every time a subscriber subscribes to the publisher, it is given a subscription. The subscription is a connection between the producer and the consumer, between the publisher and the subscriber. It's like a link, a session, if you will. The subscriber can use this to say, hey, I want more data. Okay, I want 10 more records. I want 1,000 more records. And the subscriber tells the publisher how much data it wants. This is very important. This is client-managed flow control. It's very important in building stable distributed systems. You want to make sure that you cannot be overwhelmed, okay? So we have this here. We can also cancel the rate of consumption, okay? So that's three of the reactive streams types. I did say that there is a fourth one called processor, okay? Processor. So here's processor. Here. Processor is just a bridge. It's a source and a sink. And that's it. That's the entire Reactive Streams specification. These types are so useful, they're so obvious, that they are now in Java 9, which is now more than 2 years old. So if you go to Java util concurrent flow.processor, .subscription, .subscriber, and .publisher. They're in the JDK itself now, right? So you can use both types. You can use the Reactive Streams types, of course, with older JVMs. So those types are very useful, but they're very simple. They don't provide support for filtering and mapping and operations like that. So we have two specializations, the first of which is called a mono. Mono does not mean monkey. It doesn't. It's not a monkey. No. This is a publisher that produces at most one value, okay? It produces 0 or 1 value. It has operators, though. Look at all these operators, lots of operators to do things like filtering, mapping, etc. We also have flux. Flux produces many values, 0, 1, 10, a trillion, infinite, etc. Okay? And we also have lots of operators there for you as well, right? Lots of stuff. So lots of different things you can do with these types. And these two types, mono and flux, they come from Reactor, the Pivotal API. So now let's use these APIs to write some code to the database, okay? Sample data initializer. And I'm going to write some data to the database. When my application starts up, I'm going to listen for an event, public void ready. And when the application starts up, I'm going to make my life a little easier, use lazy initialization. And I'm going to inject my reservation repository. Okay, there's this. Now I can do that the old-fashioned way. I can create a constructor like this, or I can just use required args constructor, which does the same thing from Lombok. And now I'm going to write some data to the database. So let's create some names. Okay, I'm going to say some people on the Spring team. Okay, so obviously there's me. Nice to meet you. We've got Olga. Good. We've got Dave. Okay, we've got Violetta. Okay, we've got that. And then we have Marcin. Good. And we've got Madura. Good. And we've got Cornelia. All right. And we've got Mark. Okay, so there's a bunch of names in a publisher. I've created a stream of names. And I'm going to turn each one into a new reservation. Okay, a new reservation. There we go. And there's a publisher of reservations. And now I'm going to save each one into the database like so. I'm going to pass that in. Now, the thing you have to consider here is that save, it returns a mono of reservation. And so if I call map, then I get flux mono reservation. So I say flat map, and that gives me just the publisher of reservations. Now, if I run this code, nothing will happen. You see, this code is a cold stream. We have connected pipes together, but nothing is actually happening yet. We need to now actually evaluate the stream. In order to do that, you subscribe like this, okay? Now, what I want to do first, though, is I want to clean up my code here a little bit. First of all, I would just use this, Java 12, right? Why not? I can do that. Also, you can stage things together. You can string them together in a pipeline like that, okay? So that's a little bit better, isn't it? That's a little bit nicer. But I still want to make sure that when I run the data, when I run this application, it's going to delete everything in the database first. So I say delete all. And then I'm going to say run the names. And then find the data. And then finally, I'm going to log out everything to the console. And I'm going to use a logger here, okay? Good. So there we go. There's my logger. Now, let's see what we get if we run this program. What do you think is going to happen? Let's see what happens. Let's compile it and run. Oh, look at that. It worked. It worked. Of course it worked. It was a demo. What were you expecting? That was always going to work. That's not what I wanted to talk to you about. No, my friends. What I wanted to talk to you about, as always, the thing that I care about the most, and the reason I'm here, really, I just came off of a plane 2 hours ago, so from North America. So I'm very happy to be here, and I'm very happy that we got this far in the demo. But the reason I'm here and the reason I'm so excited is because of this. This is the Ascii artwork in Spring Boot. Now, a lot of people don't understand that Spring Boot has really good Ascii artwork, some of the best in the business. We have doctors who work on this full time. So it makes me very happy to imagine that someday, somewhere, there's a GitHub issue that said we need good Ascii artwork. And we have done a lot of good work on this. And so it's for this reason that I want to talk about what I consider to be a bug in the JetBrains IntelliJ product. Even though I'm a fan, I consider this to be very, very problematic. Do you see this checkbox right here? This one right here. This one. Do you see that one right there? This one right here. Do you see this checkbox right here? Do you see that? Do you see that? That one right here. This one. That checkbox, this one, don't click that. Do you see that checkbox? If you click that checkbox, it suppresses the output of the Ascii artwork. What the hell? Why is that there? That's a dumb feature. Nobody even asked for that feature. And so I did what anybody would have done. I went on the internet and I cried. And I was given a message of hope from my friend, Jan Sebron. This is Jan Sebron right here. This is him. He's a developer advocate at JetBrains. This is Jan right here. Right here. Right here. Right here. Boop. He sent me this message of hope, which I want to share with you today. He tells me, don't worry, Josh, it'll be fixed in the next release, Josh. Just relax, Josh. And you know what? I want to believe him, but we've been friends a long time. And you know, every time there's a new release, I check and see if it's there and it's not there. He always says, don't worry, just relax. I want to believe him. He's my friend. I've known him for a long time, but I'm starting to think that maybe he's not being honest with me. Anyway, we have done some amazing things with the Ascii artwork. At all times, we're working to make Ascii artwork even better. Did you see this over the weekend? Did you see this? Look at this. Look at this beautiful thing. So now we've got 8-bit Ascii artwork. Okay, come on. So beautiful. There. So now you can do 8-bit colors in the Ascii artwork. Anyway, the future is beautiful. So now we have data in the database. We need to create a web API. We can create a web API pretty easily, right? We can actually create a REST controller, or we could use the functional reactive style. I like that style a lot. Router function, server response, okay? Server response routes, return route .build .get / reservation. So we're using the functional reactive style here, okay? And new handler function. And we're just going to return server response.ok.body. And we're going to inject the router function, or the reservation repository, I mean, right? Reservation repository.rr.findAll reservation.class. And there you go. That's the whole thing, okay? Very, very simple. Very simple little endpoint. There we go. There's our HTTP GET reservations endpoint, and that's going to produce a response in the HTTP very simply using this functional reactive style. But this is not the real reason to use reactive programming. Anybody could do 8 records from a database using something from yesterday, right? It doesn't have to be reactive to get 8 records. Where reactive programming really comes into its own is whenever you're trying to build something that uses a thread. And what things use threads a lot? Well, if you're doing a lot of input and output, this will use a thread. If you're doing things that require constant liveliness, that is, they are constantly being updated, like a stock ticker or presence or chat or something like that, then you might keep a socket open. And if you're doing it the old way, you might keep a thread for that socket. Well, this is not a problem for reactive programming. So let's create a reactive WebSocket application, okay? We're going to create a greetings service here, greetings service. And we're going to create an endpoint that returns a series of greetings, class greetings request and a class greetings response. Okay, so whenever somebody sends us a name, we're going to send back a message. Okay, data at all args constructor, no args constructor. Look at that. Okay, and take this. Good. So there's our basic DTO, greetings response, greetings request. Okay? And when somebody asks us for a greeting, we're going to send back an infinite stream of greetings. It's going to always produce a new response every second, like so. New greetings response. Hello, request.getName at instant.now. Okay? There we are. That's the whole thing. And now, there's our service. And what I want to do is I want to slow down the results. So I could leave the code as it is, but it would produce an infinite stream very quickly. So instead, I'm going to slow it down by adding 1 second of delay. Now we have a very simple service that just produces new results every second. Let's create a greetings WebSocket application, okay? So we're going to create some WebSocket configuration. And this is just going to demonstrate 3 beans, a simple URL handler mapping. This is to create the mapping from HTTP to the WebSocket. So we do that by creating an endpoint greetings and then linking it to a bean of type WebSocket handler. That's this thing right here. This is going to have the business logic, and we'll come back to this in a second, okay? That's the most important part. We're going to link that here. We're going to inject it there, okay? And of course, we need a WebSocket handler adapter. That's just infrastructure, okay? Good. Good. Now, here's the configuration class. We do need to provide that WebSocket handler adapter, and that's where our business logic will live. So what are we going to do? We're going to actually inject the greetings service, and we're going to produce a new greetings response stream, a WebSocket stream, whenever a WebSocket client connects and sends us a name. So we're going to say session.receive, get the WebSocket message, map the WebSocket message into the text, and then turn each one of those texts into a greetings request, passing that in. And we're going to turn each one of these into a call to the greetings service, passing in GR like this. And of course, each one of those is going to be a greetings response, so we'll get the message out of it. And each one of those, we're going to turn into a WebSocket text message, right? Like so. So there's that. And that whole thing is our conversation. That's the whole thing that we're going to send back to the WebSocket client. Okay, so we say session.send reply. There you go. That's the whole application. And we can clean this up a little bit. Now, in order to demonstrate this, I need to do something that I would not do normally. Okay, I wouldn't do this normally, but I can't think of an easier way to show you this. And so I do this, but I'm not proud, okay? I'm not proud of what I'm doing right now. I do it only because it's the only thing I can think of that will work. I'm going to write JavaScript. So we'll go here, source main resources, directory, static, ws.html, and in here, HTML, okay, body, script, window.add event listener, window.add event listener, load, function, okay, and here, var ws equals new WebSocket, localhost 8080/ws greetings. ws.add event listener open. So when the socket first connects, it's going to fire the on-open event. And then when we get new messages, the on-message event will be called. So when it opens, we're going to send a name. The name will be Codemotion Madrid. Okay, there we go. And we're going to say ws.send the name. Okay, and here, we're going to just log the results out. Each new message we're going to log out. So e.data. There we go. Let's restart. Okay. Okay. Localhost ws.html. Whoops, did I not? Source main resources static ws.html. Oh, yeah, there it is. So every second, we get a new response. Every second, we get the results that come back. It's going to keep doing this forever and ever and ever. Forever. As long as there's heat in the universe, this will keep producing new messages. And that's okay, because it's not going to block the thread, right? On the server side, it's not going to block the thread. So this gives us some interesting opportunities, right? We can now handle more requests with the same computer. This is not about making one request faster. It's about allowing us to handle many more requests. Okay, well now, we've got this WebSocket endpoint, we've got HTTP, we can do all sorts of interesting things here. But one of the interesting things that I wonder about is WebSockets or HTTP the best way for services to communicate with each other? And I think that they're both very useful technologies, both useful protocols, but they're not particularly fast. And the reason they're not fast is because they're not designed to be fast service-to-service communication mechanisms. They're instead meant to be document retrieval protocols. And that's fine. But a lot of organizations have looked for ways to go faster. Obviously, there's gRPC from Google. That's pretty interesting, I think. One interesting alternative is something called RSocket. How many of you have heard of RSocket? RSocket was a technology that was developed by Netflix and by people from Netflix, some of whom went to Facebook, where it's now being driven as well. There's also a company called Netify that works on it. And RSocket is a reactive wire protocol. It's a binary protocol that you can use independent of any particular encoding. It doesn't care if you're using Google protocol buffs or anything else like that. It also gets around some of the basic limitations of HTTP. So if you want to do request response, you can. If you want to do fire and forget, you can. If you want to do server initiated push, you can. And also, if you want to do binary data, you can. It also gets around some of the limitations of WebSockets. A very common example is, what if I want to do security with WebSockets? Does anybody know how to do headers with WebSockets? I'm asking because I don't know. As far as I know, there's no way to do it, right? WebSockets don't have a header mechanism. And without headers, how do you propagate things like a token for security, for out-of-band communication? And so what we're going to do is we're going to use RSocket. Thankfully, RSocket has been integrated into Spring Framework 5.2. We're using that. So I'm going to very quickly go to start.spring.io, and we're just going to create a very simple client. Very simple. And we're just going to go ahead and add RSocket. We're going to use this, RSocket, good. And we use Lombok. And we're going to hit generate and open this up. Okay. So now, what I'm going to do is I've got this existing service, don't I? I've got my service, my WebSocket, my application, my greeting service here. Instead, I'm just going to turn this into an RSocket service by saying @controller and @message mapping, greetings, okay? And that's it. Well, except for this, you have to do this as well. You have to say RSocket server port equals something. So let's say 7777, okay? And that's it. That's all you need to do to get that to work. So I'll go ahead and restart that. And on the client side, I'm going to build a thing that will that'll call the network service over RSocket, and it's going to call the never-ending stream, and it's going to stream it over this binary protocol, and then send it back to the client as a server-sent event stream. So server-sent events are HTTP, but it could be WebSockets, or it could just be another RSocket client. It doesn't really matter. So let's try that out, okay? We'll say @bean RSocket requester, RSocket requester.builder. And of course, our application has to run on a different port, so we're going to say 9999. And I'm going to say builder.build. It'll connect to a localhost 7777. And the nice thing about RSocket is that it's a stateful protocol. It's a stateful connection, so you don't have to reconnect each time. This is one of the reasons that HTTP is so slow, is that you have to constantly connect and disconnect and reconnect and so on. The network traffic there makes it very imperformant. And what I'm going to do now is I'm going to create another functional reactive endpoint, router function. Oops, I forgot that dependency, didn't I? Okay, just as a demo here. Good stuff, paste. Come on. Oh, did I do that? Look at that. Who let me do that? Shame on me. It's wrong. Okay. So now, a bean, a router function. Hello. Maven, reimport, client application, router function. Good. Server response. Okay. Whoa. And all we're going to do is just going to create a functional reactive server-sent event stream, because server-sent events is another way of sending back long-lived sort of live connections data to an HTTP client. And so we're going to say when somebody makes a request to greetings/name, we're going to send back a new handler function. Okay, new server response.ok.content type text event stream, and then the body. Well, the body will retrieve the body by making a network request using the RSocket client. Okay, so we're going to say RSocket requester dot route greetings. I don't have to specify the host and port because it's already connected, right? The data that we're going to send in is the path variable in this URL, so name. So we'll say request.path variable, name. Okay, new greetings request. And we're gonna do something terrible, something that you should never, ever do, ever. Not even when you're all by yourself at home and no one is looking. I'm gonna copy and paste code. So I've got my greetings request and my greetings response. Where are they? Here. These two things here. Okay. There are these two types. I'm gonna say greetings request, passing in the name, okay. And that gives me a retrieve flux. I'm going to say I want a greetings response that comes back. And that's the whole thing. That's my stream of greetings responses that I'm going to send back here. So greetings response, and it's going to be a type greetings response. There you go. That's the entire discussion, the entire application. Let's get rid of this verbose non-lambda code. We'll restart this. Now, there are, of course, some nice things that you can take advantage of here, like retry with a back off, and do all these sorts of things to make your application calls more performant, more stable, more robust. But for now, let's just see this work. So Codemotion Madrid. Okay. So there you go. I'm on port 9999, making an RSocket call across the wire using this binary protocol. And the data that's coming back is being turned into a server-send event stream. It could have been WebSockets, it could have been anything else, or you could just call, or some other web RSocket client could talk to it. This allows us to build stabler services more reactively. We get native support for back pressure on the wire. We get to control the rate of consumption on the wire. My friends, I think we've covered just about enough for 40 minutes. I want to say thank you so much for being here. I'm just curious, who learned something new today? Who learned something new? Very good. Awesome. Who had fun? Who had fun? Very good. Thank you so much, my friends. Thank you so much. Gracias por venir. I hope you have a wonderful day. Que tenga un buen día, okay? I'm happy to take questions. Enjoy your lunch. Talk to you soon.